I'm Fred Crick, part of the training staff at Bosch Home Comfort Group. I've got Chris Penn with me today, all the way from Portland, Oregon.
Portland, Oregon.
Welcome to Western Oklahoma, Chris.
Thanks for having me, Fred.
What are we going to talk about today?
Today we're going to talk about the A2L refrigerant change.
A change?
Absolutely.
Big, little?
It's kind of big.
Okay.
It's kind of big. As we talk about A2L, we're talking about a mildly flammable refrigerant.
Okay.
And that's kind of the new classification put on this thing. And believe it or not, we're moving to a product or refrigerant, R-454B.
So that's our choice.
That is our choice.
Was there others?
There was about six different refrigerant choices. They're all blends. We chose R-454B just for basically the longevity or the time we'll be able to use that before a new change is needed. Perhaps it's going to be in 5 years or less.
Oh, so our product will endure the change.
Absolutely.
Oh, wow.
I mean, we're hoping at least 15 years, 14 to 15 years.
Okay.
Other manufacturers that have chosen a different blend, R32, perhaps going to have to change here in about 5 years or less.
Wow. I've heard of the R32 because it was in the 410A product that we had.
A little bit. Currently, in our refrigerant change, there's actually about 70% R32, with the other portion, or the other 30%, R1234YF.
Okay.
And along with that, you know, it is the next generation refrigerant. We are using that and employing that refrigerant in all of our product lineup, except our hybrid water heater. That's going to have a little bit different refrigerant, but a little bit different scenario there. But the entire product line, mini splits, package units, all of the above is going to have the new refrigerant.
Even the water source?
Even the water source.
Ah, look at that. Okay.
Yeah, no, absolutely. Now there's some requirements or restrictions or guidelines there as far as that refrigerant goes on the water source. 60, you know, with regards to mitigation,
okay,
right? And do you need a sensor? Do you not need a sensor? And we'll talk about the sensor here in a little bit. And that number basically is 64 ounces or less. Doesn't require a sensor.
Oh.
But along with this new refrigerant, the R-454B, again being a blend, it does meet the A2L classification. It's a classification that was applied to that refrigerant. Because it is mildly flammable under the certain concentration.
Okay.
Right? Can you light it and have it, a big flame and all that stuff? No, probably not.
You haven't tried that?
No, I haven't.
Okay. All right. Good. Okay.
And basically, the new refrigerant is, this surpasses the proposed January 1st, 2025. So basically, the government came in and said, you will change manufacturing your products with the new refrigerant by that date. Again, January 1st, 2025.
So our government started the process to get it worldwide changed.
It is, exactly. Global change.
Okay.
Global change. It all has to do with that low GWP, or global warming potential, which currently sits at a number about 700, or at 700.
Okay.
Our refrigerant, our 454B, comes in at 466. Whereas the R32 that some manufacturers are using, it comes in at about 676.
Okay.
So
ours is significantly lower.
Yeah, absolutely.
Okay.
And since we're under that 500 level, which is most likely where that number is going to be in the future, is why we're going to be able to use 454 for a long time to come.
Oh wow. Okay.
Long time to come.
Good choice.
In addition to that, Fred, too, we're talking about, the environmental impact of what 454B is, because it really is all about the environmental impact. This contributes significantly less harm to the environment than 410A. 410A's low GWP number was in the 2000s, where ours sits at that 466 number. It's going to offer better compliance with the HFC phase-down initiatives under the Montreal Protocol. That's what's driving some of this. It is also a zero ODP, or ozone depletion refrigerant, so no contribution to the ozone layer degradation. And with that, the lowest EPA or SNAP approved number, again, our refrigerant falls at that 466 number, which is actually 78% lower than the 410A. So I mentioned over in the 2000s compared to the 466, that's about a 78% difference.
Okay.
Also too, along with that, there's some key definitions as we talk about this refrigerant change. I did mention low GWP and what that means or stands for, that low global warming potential. HFCs, is currently where the refrigerant sits at today, 410A. We're going to be talking about how that transitions into HFO, which is what the new refrigerant's going to be. The AIM Act, this is basically the act is mandating this phase down. So it's not a phase out, but it's a phase down. Which is
again, 15 years?
It is a 15-year phase down for sure. And refrigerant concentration limits. So there's some things that go along with concentration limits, or what we're going to also call flammable concentration limits, which is a concentration limit intended to reduce the risk of fire of explosion. And then lower flammability limit, or LFL. So these are kind of some definitions that is tied to the education part of this refrigerant change.
So in this refrigerant change, we would probably see some of those definitions and those abbreviations throughout literature and things like that.
Oh, absolutely. The first 8 or 10 pages of the IOM for us is a lot about the safety, a lot about the LFL and the FCL and so forth.
And the local contractor has to memorize all of those.
Well, I think
or familiarize themselves.
Read the manual a couple times until you get familiar with it.
Now, what'd you say? Read the manual?
I did say read the manual.
Oh my gosh!
I did say read the manual. That is going to be key to this transition. Until you get to know it and use it, you're going to have to want to educate yourself. And there's plenty of resources. We have resources on our website that you can go. You get some of these questions answered too. But hopefully we're going to try to get a lot of those questions answered today.
Awesome. What else you got?
Well, I did mention the AIM Act, right? This is, why the refrigerant change. Is basically U.S. government said, we're going to mandate a 15-year phase down. You can't manufacture product with 410A in it anymore after January 1st, 2025. And again, this is all because of those low GWP numbers that we're trying to achieve.
Wow, okay.
So, now, as we move forward with this, there's a lot of question from the contractors with regards to what qualifies. For example, products. What's a product? What's a system? What's a component? Right? And really, it kind of breaks down like this. For us, product is considered our IDP, our inverted ducted product, which is a self-contained package unit, right?
So it's a sealed unit.
Sealed unit, refrigerant all within itself. Evaporator, condenser, all in one unit. And they're giving us a 3-year sell-through period on that, or a 3-year transition phase for that product because of the nature of that product. And then we got systems. We're talking split systems, indoor, outdoor. You got a refrigerant line that attaches the two. That is labeled a system, and basically after January 2025, you're not going to be able to install a 410A system unless it's considered a component. Now let's talk about component. Component is this: outdoor unit by itself, 410A is okay. Evaporator coil by itself, 410A is okay. And then along with that, if I do choose to install those as a component, we also have this accessory kit that's needed, and that's needed just for that A2L sensor I talked to you about a little bit ago. And the mitigation. What are we going to do when we sense a refrigerant leak, right? And that's the purpose of that A2L accessory box. In the event that I'm using an evaporator coil, with somebody else's gas furnace, we call it third-party furnace connection. So those are all labeled components.
So that sensor is going to detect the refrigerant leakage if there's one there, and then do what?
Well, in the event of a leak, we're going to call it mitigation. We got to do something to dilute or disperse that refrigerant leak, right? Using that sensor under certain concentration limits, we are going to shut the compressor off, and we're going to tune the indoor fan motor to high fan speed. And, again, in the IOM that we talked about, in the beginning of that IOM, it's going to give us some limits and some parameters. You got to do a little bit of math. So it's going to determine what our square footage is, or how much allowable square footage I'm going to need to disperse or dilute that refrigerant into the home.
So diluting that gets rid of that volatile, low
flammability risk. For that. We had to do some other changes to the product, update the boards to, apply the A2L sensor to it. And there were some changes made to the indoor fan motor, make it sealed, because of that low flammability risk. So there were some changes made to that as
Right.
well.
I noticed at your slide on the systems, it shows our our IDS unit and with the electric air handler. What about our IDS unit and a case coil and a furnace? Is that a system also?
That, in this example, would not be considered a system. That would be considered a component, and that's where that A2L accessory box I was telling you about, as pictured there into the component section.
Okay.
And that is used to, again, mitigate, meaning turn the compressor off, turn the fan motor to high speed. So all its voltages and inputs and outputs would come into the accessory box, which is going to control the product. That's how we're gonna turn the compressor off.
Okay.
And that's how we're gonna turn that third-party furnace's fan motor up to high fan speed.
Okay. Awesome.
So
Good stuff.
yeah. So that's kind of how we're gonna break this down. Some of the terminology we need to use moving forward is, is it a product? Is it a system? And is it a component? Okay.
3 different areas of concentration.
Absolutely.
Oh, cool.
And each one kind of has its own different things. So how did we get here? How did this originally start? Basically, the current regulation, or what the current regulation was going to be, was we can't install or sell any of this as of January 1, 2025. And that means everything. So going back to that previous slide, we're talking package, we're talking split, and components. Well,
That had 410A in it.
that had 410A in it.
Oh my
Now
God.
that caused a lot of reaction, negative reaction, as to what am I going to do with the current
Yeah, I
product
would
that I have. And so for that reason, they did update that regulation, which is now going to allow us to sell and install it through December 31st, 2025.
Okay.
But once we get into 2026, all bets are off. So now we should be all the way through our transition, and it'll be all 454B after that. So, and also too, on top of that, the proposed change, it just basically is going to ban us manufacturing that afterwards. So we're manufacturing it now, we're gonna have that product available. We'll get through our 410A through next year, which was a great change, so that we weren't left holding product, or contractors or distributors holding product. So that was a huge change.
That's awesome.
So where's our focus? Really, our focus, between the AIM Act and this, why the refrigerant change, the main focus is heat pumps. We're talking about electrification. There's a lot of people out there right now talking about electrification, and heat pumps being part of that, as compared to fossil fuel. And so that's referencing new equipment, new criteria for installation, operation, and repair. And we'll talk a little bit about some of those things here in a bit. But we're also talking about refrigerant transportation. What are some things that we got to do with transportation, which also ties to part of this change. We're talking about mildly flammable refrigerant. Questions come up. Do I need a flammable sticker? Do I not need a flammable?
Oh, you mean on your trucks?
Oh, exactly.
Okay.
And so right now they're still trying to figure out some of those details. But right now we are aware that if you carry anything more than 500 pounds, you'd be required to have that sticker on your vehicle. Anything under that, not. But some other safety things like fire extinguishers, still going to need.
What do you mean fire extinguishers?
In the service vehicle, contractor's vehicle.
Okay.
In the event that we do have a leak, or we pop off on the pressure relief valve or something of that nature.
Does that fire extinguisher have to be on the job site at the same place that the...
Part of those safety precautions is also going to have to be on the job site as well.
Oh, wow. Okay.
I mean, it's so much so they've actually changed the components of recovery machines, vacuum pumps, brushless motors, and things of that nature.
Goodness. Okay.
I mean, we're talking about a mildly flammable refrigerant, Fred.
And we're talking about a complete change of mindset.
Oh, absolutely.
Complete change of job site situations. Okay.
So in some of my conversations, it's been, if we still continue to use our standard safety practices that we know today, in reality, and again, we'll talk about some more properties here in a second too, still continue to do that, we're going to be fine with this new refrigerant change.
Okay.
So, and then other things too that are still kind of in the progress right now, or still trying to figure things out, new building and fire codes, things that are happening out there. So there's still some more information to come A lot of this information now is preliminary and in an effort to get people more educated and not be so freaked out.
So if I'm a homeowner and I see this on the website, or if I see it on a YouTube channel, whatever it is, and I'm thinking mildly flammable, do I really need to get really tweaked out and nervous and install a fire suppression system in my house or anything like that? Is it that particular that I need to be freaked out about it being mildly flammable?
No, it's really not. Some of the term, or one of the terminology is minimum ignition energy. You know, what's it going to take to ignite this refrigerant?
Okay.
It's very, very mild.
Okay.
I mean, there's refrigerant out there. It's A3 is propane that ignites with one push of a red button.
Yep.
Right. This 454B, it's going to take 100 times that button to ignite that refrigerant.
Okay. There you go.
So with that being said, again, because of that potential is why they had to label it mildly flammable.
Go. Okay.
So what are A2L refrigerants? That's a question that everybody asks,
Absolutely.
Right? The different types of refrigerants that we have worked with today and before is the normal CFC, right? R12, I mean, we're all used to, or some of us that have been around for a while know about R12, right? That was back in, I believe, the automobile sector back in the day. And R11, that had some very high ozone depletion numbers to it. The one that I was currently, because I never worked on cars, but when I started back in 1988, it was all R22.
Sure.
And that's what I knew. You know, very, very low pressure, suction versus head pressure. And the big thing there was chlorine.
Yep.
And that was the initial change, was the chlorine damaging the ozone. From there, we moved into 410A, R32, consisting of hydrogen, fluorine, and carbon. And that's labeled an HFC. So we talk about some of these abbreviations: hydrofluorocarbon, HCFC, being hydrochlorofluorocarbon, right? Okay. And now we're into the HFO. Still has hydrogen, fluorine, different fluorine atoms versus the HFCs, which had more different carbon atoms. And that's where we're at right now with the 454B, is the hydrofluoroolefin, is what we're labeling that, the HFO. Defining A2L2 is another big one. What is A2L? I've kind of touched on it a tiny bit. But we're talking about, A refrigerants and B refrigerants. B refrigerants are more higher toxicity than the A refrigerants. But if you look there on the chart, you're looking at A3. A3 is propane. And we just talked about that minimum ignition energy on that. One piezo, one push of a red button that spark that stuff. And then you notice there the A2L is under the lower flammability, lower toxicity than the B ratings. It is still a blend, and the A2L now is used in that new equipment design that we talked about for products moving forward. So in reality, it's just plain going to be difficult to ignite.
Wow. I heard when it first came out that you were down there in Austin, Texas, and you're working in the summertime, and you heard this on the different parts of the neighborhood and stuff, and then there was a serviceman out there smoking, and he's no longer a serviceman and all that kind of thing. But that's not going to happen. No, it's really not.
It's really not. Again, it has to be under the same concentration, or I should say a heavy concentration. And there's a little bit of math there that I don't have that math memorized. Yep. But under the certain concentrations, we just have to be aware of it.
Sure.
Right?
Sure.
We just have to be aware of it. We have to stick to our standard safety practices.
There you go.
And as long as we do so, everything's going to be fine. Smoking a cigarette isn't going to go kaboom. But as long as we're aware of it, we have to be safe with it in those types of conditions.